Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about flipping off the Earth, and if I have time, sorry about irradiating you, and of course, taking listener questions about all things in the universe, because this show is about the entire universe. We record the show every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about being right all along. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. We've got an exciting show for you today on Space Radio, where we talk about all things all the time. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708. Light it up. Get those calls in and we'll have a lovely little chat. You can also follow along on the live streams on YouTube, Facebook, and Twitch. And I want to say a special hello to some of the people telling me where they're living right now as they're live streaming. We've got Salt Lake City, we've got Denver, and we've got Denmark. Check out spaceradioshow.com for the links. We'll take questions that you send there too. Seriously, folks, I prepped 10 minutes of show material. Absolutely tops. So get those calls in. Before I start taking calls, though, I wanted to share some interesting bits of news I caught recently. And there's a big splash. A lot of people worrying over the past few days about the Earth's magnetic field going away. Which, it's the magnetic field of the Earth is constantly changing. I mean, we're so used to it that there's a constant, you can pick out your compass and it can start turning, north or east or west, and it helps you get lost or, not lost anymore. And we're just used to thinking that, like everything else on the Earth, like mountains and oceans and stuff, the magnetic field is just always there. But the magnetic field is constantly changing. It's constantly in flux. It's constantly on the move and twisting around itself. And it does so. It changes on time scales that we can measure, which is such a fascinating thing to me, that we have the ability to so well measure this magnetic field that over the past 100 years, we've noticed that it's been weakening. It's been weakening over the past 100 years. Now, if you read reports about this weakening, it comes with lovely, lovely words like alarming weakening or drastic weakening. I mean, that's just not true. Okay, it's just the magnetic field of the Earth is constantly changing. What we're observing doesn't appear to be outside the norm. And of course, all these articles come with, well, what if we lost the magnetic field? Well, we'd be exposed to harmful radiation, and we'd all get cancer, and plants would die, and you wouldn't be able to get milk at the grocery store anymore. Like, it's just the worst possible scenario if we lose this magnetic field. The truth is, yes, if we completely lost our magnetic field, if it were to go away completely, over the course of a few 100 million years, we would lose our atmosphere, which is kind of lame. But it does help protect against harmful radiation. Our atmosphere itself does most of the job of absorbing high energy radiation from the sun and from outside the solar system. So even without our magnetic field, birds would be a little bit confused. We'd have to work a little bit harder to get ourselves out of the woods, but generally it'd be okay. And the Earth's magnetic field has gone away in the past, and it's bounced back. It's flipped. That what used to be north was in the south, and then it was back in the north again. It's flipped over the course of hundreds of thousands of years. This new research that all the hoopla is about is actually very cool research led by Vincent Hare at the University of Rochester, who noticed that there's a big giant chunk of rock underneath the South Atlantic. And when I say underneath, I mean like 10 or 18,000 miles underneath the South Atlantic, right at the boundary between our core, which is what's generating our magnetic field, and the relatively cool mantle. There's a big lump of stuff there, and we think that movements of this big lump of stuff helps shape and determine the flow of molten lead as it's spinning around in our core, molten iron in the core of the Earth, which is what generates the magnetic field, so that as this big lump of rock shifts around, sinks a little, rises a little, does whatever, that maybe is what causes changes in the magnetic field, but we're not 100% sure. It's active research, super fascinating, and I guarantee you have absolutely nothing to worry about. Well, I mean, you have lots of things to worry about, but magnetic field of the Earth changing is not one of them. So that's the latest and greatest when it comes to space. It's time to have a conversation. We've got a caller. Hey, Florian. Thank you for calling Space Radio. Where on Earth are you?
Well, hello there, Paul. It's good to talk to you. How has Iceland been treating you?
Oh, man, Iceland was so fantastic. Thank you for asking. We had an amazing time. We were locked in our hotel for 2.5 days because of a massive storm, but it was a blast. Just experiencing Iceland, talking about Iceland, seeing all the cool stuff. I had a good time. I can't wait to go back.
All right, on. I'm glad to hear that. Sorry about the weather, though.
It's okay. I'll deal with it. I'll deal with it.
Fair enough. I do have a question for you, if you don't mind.
Absolutely. That's why this show exists.
Fantastic. The other day, I think it was on a video on your YouTube channel, I heard you mention the Drake equation, and you mentioned that you had some concerns about something with that equation, and I wasn't quite sure, and I was just curious to hear what your concerns might be, and if you think there's any value to the Drake equation, depending on what your concerns might be.
Oh, that is such a good question. I did tease that, didn't I? I did tease that on my YouTube channel, where I was talking about the possibility of life outside the Earth, and then there's this famous equation first written down by Frank Drake, something like 60 years ago, on the back of an envelope. I think that's literally true, on the back of an envelope, where it purports to lay out all the conditions that you need in order to generate an intelligent species that we could have a conversation with. Like, okay, we need a sun-like star. We need a planet about the size of the Earth. It needs liquid water. You need all the right ingredients for life. It has to evolve. They have to not kill each other. They have to develop radio. They have to start talking. We have to be able to listen to it, et cetera, et cetera, et cetera. So the goal of the Drake equation is that as you start doing all these little individual measurements of number of stars in the galaxy, number of stars that look like our sun, number of planets that look like the Earth, et cetera, et cetera, et cetera, eventually out pops a number that tells you how many intelligent civilizations are, for example, in any one galaxy. And what Drake's original intention was just to get the conversation started. Like, let's begin parameterizing it. Let's begin thinking about it. Of course, it's taken on a life of its own, where people are taking it very seriously, that you could actually pin down these numbers. And I have a few challenges with the Drake equation. One of the challenges is that even if, let's say you parameterize it and there's 7 different variables you need to figure out in the universe. There's 7 of them. Let's say you pin down 6 of them to incredible precision. You know exactly how many stars look like the sun in the galaxy. If there's just 1 left, the uncertainty in that one parameter is going to drive all the uncertainty of your final result. And so you actually haven't learned anything. By chopping it up into pieces and pinning it down one by one by one, as long as there's 1 remaining that has any uncertainty attached to it, where you're not quite sure, then you actually haven't pinned down an answer. And there's another kind of higher level issue with the Drake equation, which is your choice of parameterization, like what you're going to call the chances of finding life, intelligent life elsewhere in the galaxy, depends on your choice of how you're going to chop up the problem. And if you happen to ignore something, if you happen to ignore that, say, oh, there's actually a lot of liquid water in icy moons around giant planets, you're going to end up with a number that's just wrong. That's just wrong. You haven't learned anything about the universe despite all this work, despite all this hard work. You actually haven't learned anything. Does that lead to any follow-on questions there?
Maybe a small follow-up. Is what you're saying that there's just so much uncertainty in the values of those parameters that it's not even useful to sort of, narrow down the possible space? It's just like it isn't even useful to give you an estimate within a couple of orders of magnitudes just to constrain the problem a bit.
Yeah, let me keep talking about this after the break. We have to take a quick break right now. Don't forget to call 888-581-0708 to join the conversation or catch the live streams on YouTube, Facebook, and Twitch. Visit spaceradioshow.com for the links. You can also follow me on social media. My name is @PaulMattSutter. I'm Paul Sutter. This is Space Radio, and this show is brought to you by our friends at Spacetime Labs, the creative agency for science. They're an R&D lab for science communication. We thank them for their design and art direction support for this show. Check them out at spacetimelabs.co. It's also brought to you by you. Visit patreon.com/PMSutter to learn how you can support the show. See you after the break. And that's just an imaginary break. We're actually going to pick up the conversation exactly where we left off. Oh, he left. Florian left. Ah. I'll keep chatting, though. I'll pretend he's still on. I can do his voice. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. I was chatting with Florian, having a lovely conversation about the Drake equation. During the break, he hung up. Sorry, I would have loved to keep chatting with you because there were some more issues to explore over the Drake equation. So I'll pretend you're still on the line and that you just asked me a really, really insightful, intelligent question to follow up the conversation, and then I'll give an actual answer to that pretend question. Remember, you can join the conversation by calling 888-581-0708 or by following the live streams. Check out spaceradioshow.com for the links. Now, we were talking about the Drake equation, why I have trouble, some concerns with the Drake equation, this equation that's supposed to guide us into thinking about intelligent life, about the prospects of finding intelligent life. And my issue with the Drake equation is that it is the pretense of knowledge. It purports, it says you're going to learn something useful about the universe, but I don't think you actually learn anything useful about the universe. Because if you leave something out, if you leave out a factor that maybe you just thought wasn't going to be important, and then it turns out to be important, but you left it out of your equation, then you have no idea how common life is in the universe. And if you start adding things or chopping up things, and then you can dig in even more deeper into the statistics that with each one of these parameters, you have to assign, if you want to do it right, you have to assign an uncertainty. You're going to do a measurement. Real measurements carry uncertainty with them. You don't actually know precisely the answer. And to do it correctly, to do the statistics correctly, is a huge pain in the neck where you don't actually learn what you think you've learned because you didn't quite follow the statistics through properly. And that's not to say the Drake equation isn't a useful way to start thinking about the question, to start framing the question, to start putting the pieces together. But it's at the end of the day, I don't think it's informative about the real universe. And that is my big challenge with that. Now, over on the live stream, the live streamers, the space cadets, should I start calling them space cadets? I think so. Oh, we've got someone back on the line. Florian, is that you again?
Oh, hello again. This is just Florian. My apologies for getting lost earlier.
Hey, no problem at all.
Did you say you wanted to sort of follow up a little bit more on that question asked earlier?
Yeah, I just did actually. So you'll have to listen to the podcast, and you'll find out my follow up. The basic takeaway, and I don't mind repeating this. The basic takeaway is that the Drake equation is not informative about the universe in the way that you hope it is.
I gotcha. Well, that was awkward with the timing there.
Hey, it's all right. This is radio. This is excellent radio. The listeners are going to love this delightful exchange.
I hope they do.
Thank you so much for calling.
Thank you so much. Talk to you next time.
All right, take it easy. Thank you. It looks like we've got another caller on the line. And hey, Jalen, how's it going? Where on earth are you? Earth to Jalen.
Hello.
Hey, how's it going?
Good.
Good. What's your question today for Space Radio?
I am in Ohio.
Nice. Jalen from Ohio, a wonderful state. You've got a question for me. What do you got?
What's your favorite planet?
What is my favorite planet? Oh, it's so... Am I allowed to say Earth? Because I live here? I mean, what is... Can my planet, my favorite planet... Am I allowed to say Earth? Tell me that.
Sorry, I can't hear you.
Oh, we're having a little bit of issue with the connection, but I'll take your question seriously. My favorite planet, of course, is Earth because I live here, and it doesn't look like I'm getting off anytime soon. So I'm going to pick Earth. Second favorite planet, though, isn't actually a planet. It's a moon, a giant moon of Jupiter, the moon Europa. I love talking about Europa. It's so intriguing to me. It is just, there's like a spark that goes off in my brain every time I think about Europa. I love it. And that's because it's encased in 100 kilometers of rock-hard ice, and underneath that 100 kilometers of rock-hard ice is a globe-spanning liquid water ocean. And where there is liquid water, there is the potential with a capital P, potential chance for life. Now, are there space whales and space bugs and space creatures and space squids floating around the oceans of Europa? We honestly don't know. Honestly, probably unlikely, but it's worth a look. It's worth a look-see to see what's going on under the ice. Now, back to the live streams. The live streamers, Space Cadets, I haven't come up with a name for them yet. The Space Cadets, that sounds, I kind of like that. Space Cadets were asking a lot about rotating black holes. And about how does this relate to things like magnetic fields? Can you pull energy out of a rotating black hole? What would happen if you slowed down and stopped a black hole? Excellent questions from all those space cadets on the live stream. Check this out. We think that every single black hole in the universe is spinning. This spinning creates an effect in general relativity that we call frame dragging, where it's literally dragging space-time around with it, where it's like if you have a heavy piece of furniture on a carpet and you start twisting the furniture around, it pulls the carpet with it, kind of sort of like that, but, in 3 dimensions. And this connects to the surrounding material, can help drive magnetic fields, the flows of gas around these black holes. We think this helps perhaps power the giant jets of radiation that come out of the poles of spinning black holes. And this does provide a way where you can tap into that rotational energy and use it as a power source. You can do all sorts of things. These are incredibly massive, incredibly fast beasts that are enormous power sources. So you can imagine a hypothetical scenario where you could actually get to a black hole, which is kind of challenging, and then you might extract some energy from it in some super fantastical sci-fi sort of way. What would happen if you slowed it down? Well, you'd have a non-rotating black hole, which is also a thing. Totally legit thing, just not very common because black holes in our universe are seeded from things that are already spinning, like stars. And so we think every single black hole is spinning. Non-rotating black hole just happens to be a special case, which is of moderate interest. But then it's time to move on to a new black hole because you've sucked up all the energy. Thank you to the Space Cadets online. Thank you to the callers, Jalen and Florian, for all those great questions. We're almost out of time today on Space Radio. Man, this show goes too fast. But before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift. By the way, I meant to mention it in the show. This isn't the show. I meant the beginning of the show. Greg has, in his little booth, he has a pen, and he has a piece of paper. And that when you call in, and he writes down your question, he writes down your name, he will also ask you for his address. I will not read your address out loud on the air because that'd be super weird, but we will send you a postcard-sized refrigerator magnet. These are so cool, and they weren't expensive at all. So we have a ton of them, and they have the name of the show. They have my name, of course, and the logo, a lovely little graphic design, and then for science emergencies, dial 888-581-0708. Hey, that happens to be the number of the show. What a coincidence. I wasn't planning on that, but actually, yeah, I totally planned on that. We're giving out free magnets, all right? Just call in and you'll get a magnet. That's the short version. Anyway, I teased at the beginning of the show about this topic if I told you I was right all along. Last night, we hosted a lecture by Mike Brown, the guy who killed Pluto and according to him had it coming, and also think that there's a new planet out there. He's calling Planet 9. Way out there. I'm talking like 50 times further than the orbit of Pluto, just ridiculously far. And you know, he has the evidence, he has the observations, he's trying to convince everyone else in the scientific world and non-scientific world that it's actually out there. And he made a very, very interesting point that really connected with me. That he said if another astronomer had published this result, his first reaction would be like, yeah, right. This culture of skepticism, of healthy skepticism, is absolutely vital to make science move forward. So do I think there's a Planet 9 out there? Probably not, but we'll see. Maybe the evidence is out there. Maybe we'll get a picture of it someday and that'll be it. And then we get a Planet 9. But maybe not. We'll see. Need more evidence to make that decision. And this culture of skepticism, of healthy skepticism, of evidence-based skepticism is so critical to science, and it's a healthy attitude to adopt in life, I think. And the reason this exists is a very selfish, very human reason. It's because proving someone wrong is one of the greatest joys that a scientist can have in their life. But the greater joy, the number one joy, is being right all along. Now that tastes sweet. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. I'm Paul Sutter. This show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Mishalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. And also catch the live streams on Facebook, YouTube, and Twitch. Go to spaceradioshow.com for all those lovely links. You can also catch old episodes in podcast form, show notes, the whole deal. Thanks again, Earthlings, for listening. And remember, science is for sharing. End of transmission. And I'm not used to the camera being over here. Hi, hey, Space Cadets. The camera used to be up here on the top of my computer, and now it's over here. So that's why I was always looking over here, because I'm used to that camera, not this camera. And I think I was going to ask all you for the name of the episode, but I think I already saw it. Someone said 99 problems, but a magnetic field ain't one. And I think that's going to be the title of the episode. What do you think of my portal to the universe? We've got a green screen going on here. We're just testing it. We're just playing around. I can do all sorts of cool backdrops that you might enjoy. Someone, I don't know, probably an intern, that can change these images on the fly to reflect the topic. That's like my ultimate dream. But we're still working on it one step at a time. Live streamer said the caller's voice was good.
Thank you.
Okay, so it was them hearing me, which was the problem, but everything was mixed okay on our end. So yeah, it must have been going through. We can go back to using the laptop.
Try that next week.
Yeah. Yeah, I know, Angelo. I get it. The delay.
Yeah, it's annoying.
It's annoying for us too, and the current music is a little loud though.
That's your fault. I have absolutely nothing to do with it.
Sam, there's no music playing. There's zero music. Okay, we'll take a while because there's a delay in the live stream. Yeah. we're working on the phone delay. We don't know. We're like every week we're troubleshooting and trying to figure out where that's coming in, and we just don't know. Oh my gosh, what music? Someone else said the current music is a little loud. There's music on YouTube? Oh. Oh. Did I fix it? So good. I didn't run this video as the backdrop because I had music to go with it. And it was louder than me. Good thing I didn't go with it. Thank you. That was something else. Mute that sucker. Okay, I get it, live streamers. I just literally figured it out. Thank you. Oh, the joys of producing the show as we go. Okay. All right, so we gotta go. We're gonna do some more tests of the phone system to figure out why it's delaying. We honestly, God, this camera's over here now. We're working on it. I promise we're working on it. All right, everyone, have a good morning, afternoon, and or evening, depending on your location in the world, or none of the above if you're in space.